Welcome to Lecture 1 for Technical and Science Graphics. Graphics and visual design are not simply matters of taste, opinion, or aesthetics. In technical and science contexts, graphics support the rationality and logic of the text, and as such, visual design must itself be rational and logical. In technical and science communication, such aspects as arrangement of information corresponds to the system of logical reasoning patterns that we all find familiar. We are used to reading formal paragraphs, for example, in patterns like chronological, spatial, partition, general to specific, cause and effect, problem solution, and definition. Here, for example, is a typical arrangement of information as found in a research report on copulation among fruit bats. Notice here how the information is presented in a way that emphasizes a sequence of events, as highlighted by such words as during, subsequently, at this time, and after. Graphics in the form of timelines recreate visually this pattern of information. This graphic, for example, must accommodate such an enormous span of time, from the beginning of the Earth to the present day, that its line is curved into a spiral. Some visual depictions of time are complicated by the coincidence of multiple events, an apt occasion for using Gantt charts like this one. Here's a paragraph from a U.S. patent that illustrates a different arrangement of information. Here, ideas are presented in a way to emphasize the analysis of some unit into its component parts, as noted here by keywords like consists of and comprising. The graphical equivalent of such a description is the familiar exploded view. Here's a paragraph from another research paper, this one about the effects of running a car over human feet, that illustrates yet another arrangement of information. Notice here the movement from general abstract language, like process and situation, to the more concrete specific language, like VW and front tire. This arrangement of ideas, in fact, is commonly referred to as general to specific. The visual equivalent of this pattern is the photograph, always a vivid depiction of a very specific example. This one to illustrate dental fluorosis. Thus, the textual arrangements of information have their counterparts in visual design. Timelines, for example, correspond to chronology. The exploded views correspond to partition. And photographic specimens correspond to general to specific. There are others. So, just as we might ask the text about the VW whether the example is typical and representative of, quote, the parking situation, so we might ask of the picture of the discolored teeth whether the 8-year-old New Zealand child is a fair example of dental fluorosis. Likewise, of the exploded view of the toilet, we might reasonably ask whether this breakdown into components is adequate. Does the analysis account for all of the important parts? And are all parts represented in a balanced way? Here, for example, the added spacing between parts compromises the fidelity of this depiction of the porcelain altar, but it spreads out the diagram so that all parts can occupy a fair portion of the page. The point here is that visual elements in science and technology are not simply window dressing. They in fact reinforce and reiterate the precise logic of the text that they're supposed to support. As such, they can be chosen and assessed according to similarly logical and rational criteria. Such assessments are the focus of this course. This concludes Lecture 1.